Okay, in this next video, we're going to start looking at how to do what we did in the last one with adding and subtracting fractions, and now talk about the idea of mixed numbers. All right, so first we need to know how to convert between mixed numbers and improper fractions. In order to perform the operations of fractions that contain mixed numbers, it's easiest to convert them to improper fractions. With multiplication and division, you're going to find that you have to do that. With addition and subtraction, you don't have to, but it's just easier. And I'm going to show you using that method. Once you perform the operations on the fractions, you're going to convert your final answer back into a mixed number. So let's go ahead and practice that. All right, so first I need you to know how to convert a mixed number to an improper fraction. So if I have 3 and 1/6 rather, what I need you to know is that if I visualize this, this is 3 whole items and then plus 1/6 of another one. Okay, so if I split something into 6, something like that. So I've got these 3 whole things plus 1/6 of another one. So what I want to do is how many pieces are there in this picture? Easiest way to do this, get the common denominator. If I split all of these into 6, that means this is 6, 6, 6, 6, 6, 6, and then plus 1/6 more. 6, 12, 18, plus 1 more makes 19, 6. Now, there's an easy way to get this without drawing a picture, but that's what this is coming from. So 19, 6. Think of this as you ordered 4 pizzas, and let's say you're just very hungry. You know, let's say it's a family of people. Each pizza is cut into 6 slices. 18 of the slices were eaten from the 3 old pizzas that are gone. And then you ate another slice maybe later on. And so a total of 19 slices of pizza were eaten. Each pizza was made up into 6 slices. So this here, you could think of this as each one broken down into 6 pieces, and there were 3 whole circles. So you take 6 times 3. Well, this 6 here tells us how many are in each whole. And when I take it times the number of whole numbers that I have, that's where I'm getting that 18 from. So 6 times 3 makes 18. Once I know that, I'm going to add the 1 more that I have, and that's where I get the 19 from. So the shortcut way to do this is you take your denominator times the whole number, and then add the numerator. And you'd write that as 19, 6. Here's another example. This time I won't draw the picture. Well, I'll do it both ways. Let's start by taking each piece now is made up into 4 sections. I have 2 whole things with 4 in each section, so it's going to give me 8. And then I have 3 more of the next one, so that gives me 11 fourths. If I draw a picture of this is my 2 wholes. Here's my 3/4 of another one. So if I split this into fourths, here's my 8/4 plus 3/4 more, which makes 11/4. Okay? So that's how we're getting the idea of the improper fraction. And we call it improper because the numerator is larger than the denominator. All right, now what if I need to go the other way? What if I have an improper fraction and I need to make it a mixed number? Well, for this one, we just have to use our trusty friend long division. So I see that I've got something broken into groups of 5, so I'm going to see how many times 5 goes into 17. Well, 5 goes into 17 3 whole times. Those 3 whole groups of 5, I subtract that out from my 17, I have 2 left over. So I have 3 whole groups, and then I have 2 left out of 5 that each one was made up into. So 3 2/5. Okay? And if you wanted a long drawn out way to think about this, if I have 17 fifths, if I split each one of these into 5 sections, oh, it's terrible. Oh, I'm not really gonna be able to draw this very well. But just kind of know that it'll do something sort of like this, I guess. There we go, that's a little better. So 5 fifths, 6, 7, 8, 9, 10 fifths, 11, 12, 13, 14, 15 fifths. And I would need 2 more to make my 17 fifths. So that's 3 whole circles plus 2 fifths of another one. So that's kind of the visual version of my answer of 3 and 2 fifths. 28 ninths. I am not drawing circles with ninths, so I'm just going to do this using the algorithm. So 9 goes into 28. Let's see, 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. Oh, that's pretty close. I have 1 left over. Okay, so my numerator this is my quotient. That tells me my whole number of circles. So I have 3 whole circles. This tells me I have 1 left over out of 9. So 28 ninths is the same as 3 wholes plus 1 ninth of another one. Okay, so 3 and 1 ninth. Okay, we're going to use that idea to help us add and subtract mixed numbers. Okay, so when adding or subtracting mixed fractions I should say, any fractions, you want to make sure you get a common denominator. If you have mixed numbers or whole numbers, convert them to improper fractions before you find the common denominator, and then simplify as necessary. So if I have 6 and 6 sevenths plus 1 and 3 sevenths, first thing I'm going to do is convert these into improper. 7 times 6 is 42. 42 plus 6 is 48. So this is 48 sevenths. Here I have 7 times 1, which is 7, plus 3 more, which makes 10. Okay, so this looks like what we did in the last lesson. 48 sevenths plus 10 sevenths makes 58 sevenths. Okay, now please don't stop there because it says write your answer as a mixed number in simplest form. This is improper. Okay, so we want to figure out how many times 7 goes into 58. 7, 14, 21, 28, 35, 42, 49, 56. 8 times 7 makes 56. So I have 2 left over. This will be 8 and 2 sevenths. Okay? 8 and 2 sevenths. Okay? Alright, next one, same idea. I'm going to take 8 times 3 to make 24. 24 plus 7 is 31. Here I'm going to take 8 times 1, which is 8, plus 5 more to make 13. Numerators are going to be added, denominator stays the same. 31 plus 13 is 44. Okay, I'm already noticed, well, you know what, let's turn this into a mixed number first. 8 goes into 44. Let's see, 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, 8 times 5 is 40, that's probably as close as I'll get. And I have 4 left over. So this will be the same as 5 wholes and 4/8 of another one. But that 4/8, it says make sure this is in simplest form. So if I take my 4 and my 8, I have a 4 that's in common with those. So this is going to be 5 and 1/2 as my final answer. Okay? Subtracting mixed numbers, same idea. Again, these have common denominators already, so we're just gonna change to improper. 9 times 6 is 54. 54 plus 5 makes 59. And here, 9 times 1 is 9. 9 plus 7 is 16. So I do 59 minus 16, which is 43. 9 goes into 43. Let's see, 9, 18, 27, 36, 45. Oh, 45 is too far. Subtracting these, I get 7 left over. So this is the same as 4 and 7/9. Okay. All right. We'll do, let's see, I think this is the last one of the type I want to do, and then I'll work with different denominators later. All right, so 8 times 5 is 40. 40 plus 1 more makes 41/8. Here I have 8 times 3 is 24. 24 plus 7 is 31. Okay. All right, 41 minus 31 is 10, so we get 10/8. 8 goes into 10 one whole time, with 2 left over, so this will be the same as 1 and 2/8. But hopefully we know that with 2 in the 8, we can divide those by 2. We get 1 and 1/4. Alright, that's where I'm going to leave this video. So we'll talk about doing things with different denominators in the next video.